Hello everyone. The topic which was discussed previously, it was about calorific value and analysis of coal. In this we have discussed about what is calorific value, HCV, LCV and Dulong's formula, analysis of coal, proximate analysis and importance of proximate analysis. Now we are going to discuss about ultimate analysis. About ultimate analysis measured for carbon and hydrogen. About 1 to 2 gram of accurately weighed coal sample is burnt in a current of oxygen in a combustion apparatus. Carbon and hydrogen of the coal are converted to carbon dioxide and water respectively. The gaseous products of combustion are observed respectively in potassium hydroxide and calcium chloride tubes of known weights. The increase in weights of these are then determined. Percentage of carbon it is measured as increase in weight of KOH, which is potassium hydroxide tube, into 12 into 100 by weight of the coal sample taken into 44. Then the percentage of hydrogen is measured as increase in weight of calcium chloride tube into 2 into 100 by weight of coal sample taken into 18. In this 44 and 18 are molecular weights. Significance of ultimate analysis. For carbon and hydrogen, greater the percentage of carbon and hydrogen, better is the coal in quality and calorific value. However, hydrogen is mostly associated with a volatile matter and hence it affects the use of which the coal is put. Also, higher the percentage of carbon in coal, it reduces the size of the combustion chamber required. The amount of carbon, the major combustible of coal depends on the type of coal and its percentage. It increases with rank from lignite to anthracite. Thus, percentage of carbon it forms the base of classification of coal. Nitrogen has no calorific value and hence its presence in coal is undesirable. Thus, a good quality coal it should have very little nitrogen content. Nitrogen. About 1 gram of accurately weighed powdered coal it is heated with concentrated sulfuric acid along with K2SO4 as a catalyst in a long necked flask called Geldol flask. After the solution becomes clear, it is then treated with excess potassium hydroxide and the liberated ammonia is distilled over and absorbed in a known volume of standard acid solution. Then the unused acid is then determined by a back titration with standard NaOH solution. From the volume of acid used by ammonia liberated, the percentage of nitrogen in coal is calculated as follows, where the percentage of nitrogen is volume of acid used into normality into 1.4 by weight of coal. Sulfur is determined from the washings obtained from the known mass of coal using a bomb calorimeter for determination of a calorific value. During this determination, sulfur is converted to sulfate. The washings are treated with barium chloride solution when barium sulfate is precipitated. This precipitate is then filtered, washed and heated with constant weight. The percentage of sulfur is measured as weight of barium sulfate obtained into 32 into 100 by weight of coal sample taken in bomb into 233. Similarly, the ash content and oxygen content is measured. Ash content is determined it is determined as proximate analysis. As for oxygen content, it is determined as the percentage of carbon, hydrogen, sulfur, nitrogen and ash. Sulfur. Although contributes to the heating value of coal, yet on the combustion produces it acids as sulfur dioxide and sulfur trioxide, which have harmful effects on corroding the equipment and also cause atmospheric pollution. Sulfur is usually present to an extent of 0.5 to 3% and derived from ores like iron pyrites, gypsum, etc., which is our mines along with the coal. Presence of sulfur is highly undesirable in coal because it is used for making coke for iron industry since it is transferred to iron metal and badly affects the quality and properties of steel. Moreover, oxides of sulfur pollute the atmosphere and leads to corrosion. Oxygen content it decreases the calorific value of coal. Higher the oxygen content coal are characterized by high inherent moisture, low calorific value and low coking power. Moreover, oxygen is in combined form with hydrogen and coal and thus hydrogen available for combustion is lesser than an actual one. An increase in 1% oxygen content it decreases the calorific value by about 1.7% and hence oxygen is undesirable. Thus, a good quality coal should have low percentage of oxygen. Thank you. In this topic, we have discussed about what are the proximate analysis, what are the ultimate analysis importance and their values.